So, good evening to all of you. Right now, I am fine, not too much, but I am fine. Yesterday, the day when I was taking your class in the evening, day before yesterday, little bit I was feeling headache, too much headache it was there. And the day before, yesterday also I was feeling some kind of same situation. So I thought it will be better to take a rest. Maybe some issues should not be there, like what it is, corona and all it is going on. But hope so I am better now. So again, good evening to all of you. I am okay now, right now. I am okay. I am always okay. Even I am 10% not in okay, that even then I am okay in condition. Condition is okay right now. Little bit. Good evening. Yes, I am trying to speak loudly. Must be it is loud to you. Must be loud. Huh? So, everyone, good evening everyone. So, today in the last classes we have understood in much better way for the space technology in the form of low Earth orbit, geosynchronous Earth orbit, what are the application of it, and we have also understood medium Earth orbit, and in the geosynchronous Earth orbit there is a geostationary Earth orbit, and how it is helpful in telecommunication, how it is good in for I said broadcasting, it is for the navigation, for the weather forecast, and it is for tele-education, telemedicine, and at the same time it is good for SOS. These are the way that it is working much better for the country like India. And at the same time we have seen how do the navigations are, how many satellites we need at least for this in the IRNS, Navic 7, you know that 3 in the geo and 4 in the geosynchronous and 3 in the geostationary. And we have also seen, like I said, that why it is medium Earth, why there is no any other kind of satellite but the navigational satellite that they I said navigational satellite of USA GPS system, and Galileo of Europe, and I said GLONASS of Russia, and BDS system of China. And now today we have to go on a very good topic, and I will finish with this. I said that different types of orbit in a half an hour time it will finish, not too much, but I said another is I said that geosynchronous transfer orbit, or it is also known as Hohmann transfer orbit, geosynchronous transfer orbit, or better to say Hohmann transfer orbit. I said like suppose I have I said that this is Earth, and I said that this is our Earth, and I launched in a satellite, and this satellite come into the low Earth orbit, and this satellite is moving in circular. This satellite is moving in circular orbit, and here it is coming, and you know that when the satellite goes into the upper space, they have also two things. They have solar panel. They have the solar panel, and in the solar panel you can be able to see, like I said, they are making their energy which is required for rotating, revolving. Sometimes they need energy, and sometimes they need also energy in the case of darkness when the sunlight is not coming, that there is some energy of in the form of radioactive in batteries are there. So, as I have said earlier, so I said, and it is suppose 2000, it is I said that suppose 1500 kilometer. This orbit, in the low earth orbit, a satellite is moving like this, and what happened, and thereafter what will happen, so he can put in a, I said that some energy over there. So, when it is when the satellite is coming at this side, they can put some, when the satellite is here, so they push some energy, and when it is putting some energy, then it is coming out of the orbit and it is taking an elliptical orbit. It is taking an elliptical orbit, and again when the satellite, again when it comes over there, when again it is coming in this region, the same, and again that energy, again this satellite is giving energy, and again it is getting extra energy coming out of the little bit orbit, and again it is taking an elliptical orbit and again coming back. Again the same way it is coming here, and thereafter it comes into, it comes here at a height of, I said that 36,000 kilometer, at a height of 36,000 kilometer, listen here, and thereafter it is putting an energy here, and then after putting the energy, it is moving in a large orbit, and slowly and slowly it is coming into the large circular orbit, that I can say here. The first it is moving into the, I said that circular, then he started taking some kind of what, elliptical, by putting the energy. Then after coming at the height of 36,000 kilometer, now he is 36,000 kilometer, now he is putting energy here to make it little faster and move into this orbit. Now slowly and slowly he started moving in a large circular orbit of 36,000 kilometer. So that is, I said that 35,786, all of you know that it is a geosynchronous earth orbit. So this is the first one, this orbit is known as Leo. This orbit is a circular orbit and it is a Leo, and how with the help of few energy I can reach to the 36,000 kilometer. So what I will do, every time I said that when this satellite is moving and coming into this region, he is giving the energy at the back and coming into the, I said that little bit out of the orbit, and started taking elliptical, and again it is coming here, again it is coming, second time it is coming here, again putting energy and coming into the little large elliptical orbit. So these elliptical orbits are known as geosynchronous transfer orbit or Hohmann transfer orbit. Means this is the elliptical orbit which help in transferring the satellite into the geosynchronous orbit. This is the orbit, these are the elliptical orbit which are helping the satellite to come at the 36,000 kilometer, and after coming 36,000 again, here it is putting the energy and started slowly and slowly moving into the what, large orbit, and here it is circular. So can I say that though there is this is in a circular orbit, this is circular, but I said that these are elliptical, and elliptical, these elliptical orbits are considered in a Hohmann transfer orbit or geosynchronous transfer orbit. So what this orbit does, geosynchronous transfer orbit connects two circular orbit of different radii or different radius. Better to say that it is in an elliptical orbit, geosynchronous transfer orbit or Hohmann transfer orbit. It is an elliptical orbit which connects two circular orbit of different radii, or it can be from the smaller radii circular orbit to the large radii circular orbit. You can be able to see here, like I say that you can see here that here it is moving, and then here slowly, and the elliptical orbit is becoming slowly and slowly a large circular orbit, and you can also see here in the same way. Suppose this is the earth, and initially here this I said that in the circular orbit the satellite started coming, then by putting the energy, they started taking an elliptical orbit, and thereafter it comes over here, and when it is coming over here, then it started putting again energy at this height, and when this height it is putting the energy, then it is coming out like this, and again burning the I say that fuel, and then again coming into this, and after that again it is able to cover the 36,000, and it started moving in a circular orbit, and everywhere it is 36,000 kilometer far. So this is the way we can be able to say that particular I said that elliptical orbit, this elliptical orbit is connecting this smaller circular orbit to the large circular orbit. Means with the help of once I need energy to transfer into the circular orbit. So we launch with the satellite launch vehicle. So it is able to come at this height, maybe 1500, maybe 800 kilometer, and after that I make it to move into this smaller elliptical orbit, then able to come over here. And when we are able to come over here, then I started again putting the energy, and slowly it's come to the large circular orbit. So this is these elliptical orbits. I say that these elliptical orbit is known as geosynchronous transfer orbit, or better to say that home and transfer orbit. Remember that. And in the similar way, we can be able to say that these are the orbits are there. In the similar way, the Chandrayaan 1 and Mangalyaan 1 has been also sent. Chandrayaan 1, it is by the PSLV, and then Mangalyaan 1, it is also by the Polar Satellite Launch Vehicle. I will discuss today PSLV and all this. So this is the same way we can be able to say that this is our Earth, and here it is, suppose it is our moon. This is the moon. Here it is moon, and moon is, you know that 3 lakh around 86,000 kilometer on an average, it is far from the earth. So it is very far, 3,86,000, and with the help of little energy, how to move. So first what will happen, the same way we'll have to do as we have done in the, I said that case of home and transfer orbit. First it came into the circular orbit, and thereafter here it started doing what? Putting the energy, and then it becoming elliptical orbit, then it is elliptical orbit, again putting the energy, burning here, then again it is coming into the elliptical orbit, again burning here, again coming into the elliptical orbit, little large, only burning here. Because once you have established yourself a satellite established in the orbit, so by using very less energy it keep on orbiting, because it is free. Moment of inertia means, you know that there is an inertia of motion is there. If you keep on moving, then it will keep on moving, because there is nothing to obstruct. Yes, few things obstruct means if there is a debris will obstruct, then the satellite will vanish, finished. But there is no obstruction, it keep on moving, but by putting energy here it is coming here. So once, and then again it is coming and coming, just yahan par this section it is putting the similarly, then slowly it come under the gravity of moon. And when it come into the gravity of the moon, then it is moving like this, and slowly come into the orbit of moon. And this is the way Chandrayaan 1 has been reached in 2008 in what I said that in similar fashion. This is the home and transfer orbit, or better to say geosynchronous transfer orbit. We are able to send our, I said that, satellite in around the moon. And in the Chandrayaan 2 that it is has been we have sent with the help of GSLV Mark 3, that is also it is able to reach here it the same way. And in the similar fashion we can send, in the similar fashion there is an earth, and here it is a very far moon, Mars. In similar fashion, we can say here it is once you have to take now what? Several elliptical orbit, and only the energy will be at this time, only few push coming out, few push coming out. The one movie has come, if you have seen Mangalyaan, the same aspect they have shown over here, you can be able to see, and then slowly and slowly coming into the large, and then in 2013 our Mangalyaan has been sent. But you know that this Mangalyaan is around 4 crore kilometer away, and it is around, I said that, so it has taken Mangalyaan has taken around 299 days. Okay, so jitna far hoga bar elliptical again and again. So perhaps you understand what is the meaning of geosynchronous transfer orbit or home and transfer orbit. So we can say that it is an elliptical orbit which connects, it is an elliptical orbit which connects the two different circular orbit of different radii. Yes or not? It is an elliptical orbit which connects I said that two circular orbit. It is an elliptical orbit which connect the two different circular orbit of different radii. So we have been able to understand home and transfer orbit. Another one, it is, I said that graveyard orbit. Graveyard. If I talk about graveyard orbit, and this is, I said, and suppose there is an earth, and earth is here. So we have, I said that low earth orbit, we have some medium earth orbit, and we have I said geosynchronous earth orbit at 36,000. So if you know that if I am talking about there are the satellites of LEO, satellites of MEO, if they after a 5 years, maybe 10 years, after a 15 year, 20 years of their operational life, they will become useless, and they have to be, I said that, coming out of this orbit. So they will remain here and there, yes or not? So the satellites of LEO and the satellites of MEO, listen me, satellites of LEO and satellites of MEO after operational life, after operational period, they convert into space debris. You can't pull it downward, you can't pull it MEO toward this downward. There will be a chance of, I said that, collision with the other satellites, and then it can cause further more debris. So let it be little bit changing the radius, changing this one, if it is moving like this, little change and then moving the different orbit and remain over there in the space. So I said that this is the way. Right now we do not have any such technology so that we can remove it. जैसे हम लोगों ने net फेंका and then catch it and return it back. There is no as such, I said, the technology to remove the debris from. So LEO and MEO will remain as a debris. But what about the satellites in the GEO? So what we can do, because up to the GEO there is a rotational revolution period is 24 hours, and after that there is nothing we required. Our satellite will work when it will be according to the Earth, and the rotation period of Earth is 24 hours, then we can be able to get the benefit in much better way. Means any satellite should move around the Earth 5 hours, 6 hours, 7 hours, 8 hours, 2 hours, 1.5 hours, maybe 24 hours, not more than that. So what happened, हम लोग when any satellite is moving in the GEO 35,786 or 36,000 kilometer above, so if their operational life finished after 15 years, then I'll give some speed so that it can come out of this GEO. And how much it came out? 300 kilometer above GEO. So what is the GEO? 36,000 kilometer, or better to say that 35,786. and when it comes above 300 kilometer and thereafter it keep on moving into this, and that is known as a graveyard orbit, and thereafter it keeps on moving into this circular orbit that is a 300 kilometer above geo, and it is known as I said that graveyard orbit. So we can say that this is our geo, this is our 36,000 kilometer, yes, above the earth's surface geo. And when the operational life finished, then what will happen? I'll put the satellite to little bit more speed so that it can leave the orbit, and after leaving the orbit it moves here and come into what I said that 300 kilometer above, and it remain, it means I have given it to the space graveyard. So that is considered as a graveyard orbit for only geo. It is a graveyard orbit for the geo. After the operational life of geo satellite, means geosynchronous satellite or geosynchronous earth orbit satellite or geostationary satellite, when their operation life finished, then that they have been shifted 300 kilometer above, and they remain over there, and our satellite never goes over there. So I will put into the graveyard orbit whenever I said that when the satellite of geo is what I said that operational life has been finished. So this is your graveyard orbit. So perhaps it is clear to all of you. Yes. Clear? So we have been able to see, like I said, that what is the graveyard orbit, and we can also see here it is I said that another point that we have to see that what is I said that one, it is a retrograde, another is a prograde orbit. Retrograde or and prograde orbit. What is retrograde orbit and prograde orbit? Suppose I said that rotation of earth is like what? Rotation of earth is from west to east. Rotation of earth is from west to east. If the earth is rotating from west to east, and in the similar way, not completely in the similar way, when the rotation of satellite is also in the same direction, same way. When the satellite is also moving in the same direction of the rotation of earth, in the same direction of the rotation of earth, that is known as prograde orbit. Means direction of rotation of earth and direction of revolution of satellite is same, then it is known as prograde orbit. Prograde orbit. Clear? Prograde orbit. When the satellite movement and then earth rotation movement same, it is known as prograde, and if it is opposite, it is known as retrograde orbit. Rotation of the earth is and the revolution of the satellite both are opposite, then it is considered a retrograde orbit. Perhaps it is clear to you. And another we have to see like Lagrangian point. We have to see another, it is I said Lagrangian point. So I said Lagrangian point. So we have been able to understand, I said that geosynchronous transfer orbit which is an elliptical orbit, then we understood it is also known as home and transfer orbit. Another we have been able to see, like I said, that the graveyard orbit, then prograde orbit, and then retrograde orbit. The next point it is I said that we have to discuss about that it is Lagrangian point. Lagrangian point or halo orbit. Lagrangian point or halo orbit. Lagrangian point or halo orbit. You should have a better vision and imaginary aspects of your mind. You know that this is our sun. It is sun, and here we have Earth. This is the Sun and here it is Earth, and you can say that the distance between Sun and the Earth we can be able to say like it is 15 crore, or better to say 150 million. Average I said that, otherwise it is 14 crore 98 lakh, and sometimes it is aphelion, sometimes perihelion, that you have to study in the geography. So here it is around we can say that 15 crore kilometer, or we can say that 150 million kilometers. So the distance between Earth and Sun is this. Clear? So now there is one point I said that I am discussing with you, that another point, it is a Sun is here, and here it is I send a satellite this is our satellite, and this satellite is 15 lakh kilometer away from the Earth. I am talking about 15 lakh kilometer away from the Earth, this satellite. So just I am making another picture of it, one visualization it is clear, another visualization I am making here. This is your Sun and this is your Earth, and here from the Earth there is I said that a distance is 15 lakh kilometer, and here it is what is happening, listen me carefully. This is our satellite. This satellite is facing what I said, that force of gravity, gravitational force toward the Sun. Every planets on the Earth, every heavenly bodies in the solar system, they are facing force of gravitation towards the Sun also, yes or not, and they are also revolving. So it means they are also facing in a just opposite side one centrifugal force. So that it is I said that that here it is the Sun is putting what Sun is putting one gravitational force and force of centrifugal, and both are equal. Here it is, both are balancing this satellite. At the same time Earth is also putting gravitational force to the satellite towards Earth, and then satellite is feeling centrifugal force away. So there is an Earth is also, according to the Earth, is also putting gravitational force, and that is equal to the, when it is putting gravitational force towards it, at the same time this satellite is also feeling a centrifugal force away from it. So we can be able to say that this Earth is, due to the Earth there is a force of gravitation and centrifugal force to the satellite, and due to the Sun there is a force of gravity and the centrifugal force. Means these are making them to be in a stable condition to the satellite. Means at 15 lakh kilometer away from the Sun, at 15 lakh kilometer away from the Earth, at 15 lakh kilometer away from the Earth, the gravitational force applied by Sun and Moon on the satellite, again I said that 15 lakh kilometer away from the Earth, 15 lakh kilometer away from the Earth, gravitational force applied by the Sun and Moon on the satellite, and then centrifugal force applied by the satellite are making satellite to be in stable position, stable position, and that point is known as Lagrangian point. Again I said that very simple definition and understanding. I said that That is, the two things are gravitational force, and who is applying gravitational force on the satellite? Sun and moon, that I am talking about. And the satellite, with respect to this gravitational force, they are applying what? Centrifugal force to remain in the stable. So I said that again at a, तो अब हम I will not write 15 lakh kilometer. I said that at any point between Earth and Sun, or along the Earth and Sun, at any point between Earth and Sun and along the Earth and Sun, at any point between Earth and Sun, along the Earth and Sun, where satellite is facing, satellite is in a stable position, satellite is in a stable position, satellite is in a stable position under the influence of gravitational force, under the influence of gravitational force applied by the Sun and Earth, applied by the Sun and Earth, and the satellite's centrifugal force, under the influence of gravitational force applied by the Sun and Earth and satellite's centrifugal force. Again I said that at any point between Earth and Sun and Earth, or along any point between Earth and Sun, a satellite is in stable position, a satellite is in stable position under the influence of gravitational force applied by the Sun and Earth, and in reply centrifugal force applied by the satellite. So this point is known as a Lagrangian point, and that orbit is known as a halo orbit. That orbit is known as halo orbit. So we can be able to see, like I said that, so if it is, I said, if it is a Sun, if it is Sun and if it is Earth, then this point is known as L1 Lagrangian point 1, which where the I said that it is in a stable position 15 lakh. Similarly, we are able to find we are able to point opposite to the Earth. So this is the Lagrangian one, that is clear to you. Similarly, I said that this is, I said Sun at the center, I said Sun at the center, and here it is L1. So this is the L1, this is, I said that L2, and this is, I said that L3. So Earth is keep on revolving around the Earth, around the Sun, but there are in the same line 3 Lagrangian point has been found. Jahan par where there is a gravitational force, this Lagrangian point is also Sun is applying gravitational force, and the Earth is also applying the gravitational force on this L3. And they are applying, I said that centrifugal force away. So it means I said that L1, L2, L3. L1 समझा दिया, no need to go for what is the how it is L2, L3. This is the physics itself. So simple one is smaller one. I said that this is the Sun, this is L1, this is L2, this is your L3, this is your L4, this is your L5. And we can say like, and here it is your, I said that Earth, and you can say that this is your Earth. So these are the 5 Lagrangian points between Earth and Sun. So in which they will remain in stable position, they will remain in the stable position. And it is also known as a halo orbit. Halo orbit. यहाँ पे once the satellite reached here, without losing energy, they will keep on watching towards the Sun. This is this side is Earth and this side is Sun. So it is here and keep on watching towards the Sun. Getting my point? And he tried to study how do the solar flares are coming from the Sun. How do the why do there is an intensity of the Sun is very high. Why do there is a corona Means every kind of study they are doing, and 24 hours into 365 days, there it is, it will keep on watching and doing some experiment and observation to the sun. So, this is the Lagrangian point is especially for the sun and earth. If I say that it is for the study of sun, and if somebody asks how many Lagrangian points, so there are 5 Lagrangian point. There are 5 Lagrangian point, and where that satellite will be remain in what calm condition, remain stable, no loss of energy, and remain over there and keep on, I said that, watching toward the sun and observing and doing experiment. And here you can be able to see so this is, I said that, our earth, and then we have, this is Lagrangian point 1 between the sun and earth, this is the Lagrangian 2, and this is our Lagrangian 3, and here it is what I said that Lagrangian 4 and Lagrangian 5, and you can be able to see L3, L4 and L5, they are making 120 degree with each other. Okay. So, and if you join this point, it will make an equilateral triangle also. The L3, L4, L5 will also make L3, L4, L5 making equilateral triangle. So, this is about the Lagrangian point, and in the recent phenomena in the 2020, we are sending Aditya, Aditya means sun, for studying the sun we are sending Aditya L1. So, one of the satellite will able to reach 15 lakh kilometer away in this halo orbit, and there it will keep on studying the sun different aspects, and I will do Aditya L1. It is an Indian space program in the, when I will come on to this Indian space program. Probably today we will go for, I said that, finishing satellite launch vehicle. So, we have finished with, I said that, Lagrangian points. Beta, the Lagrangian point can be between earth and moon, any two heavenly bodies के बीच में हो सकता है, anywhere they can remain in the stable position. So again let me tell you, so many times I have said this definition, so many times I said this definition, I said I never say the same definition because I never wrote, means कभी नहीं रटता हूँ. So please, again what I said that Lagrangian point is a point between earth and sun, और बहुत अच्छा कहूँ तो it can be between any two heavenly bodies, it can be between earth and moon also, Lagrangian point, जहाँ पे satellite will remain in the stable position. It is, and but what I am talking about right now, it is very much important because it is, we are going to send a satellite in the 2020 itself, Aditya L1. Aditya L1 to study, Aditya means sun, to study the sun in the Lagrangian point 1. So it is in a point, where the satellite will remain in a stable position under the influence of gravitational force applied by who is applying gravitational force? Sun and earth. And who is finding centrifugal force? यदि एक खींचेगा तो दूसरा क्या feel करेगा? One is pulling, then other will feel centrifugal force. So it is in a point between, earth and moon, earth and sun, earth and sun. It is a point between or along earth and sun, where gravitational force applied by the sun and earth and the satellite centrifugal force make the satellite to be in stable position, satellite will always be in stable position, and that position, that point is known as halo orbit. Completely okay. And we are going to send one Aditya L1 satellite in 2020, this year itself. There is some, maybe it can extend to the 2021, maybe due to because the corona period has I said that extended so many things. So we have planned to send it is 2020, but it can go into the Aditya, sorry, it can go into the 2021. So I will discuss this Aditya L1 when I will start, when I will do the Indian space program. So we have finished with, I said that we have finished with the orbits. First we have seen like geosynchronous transfer orbit or Hohmann transfer orbit, clear. Next one we have seen graveyard orbit. Thereafter we have seen prograde orbit and retrograde orbit. Then we come to see what is Lagrangian point or halo orbit. Now we are going to start with, I said that launching vehicle. Launching vehicle. Launching vehicle. So we have I will explain later on, but you can also, all of you, Lagrangian 1, Lagrangian 2, Lagrangian 3, Lagrangian 4, Lagrangian 5, all are beta, all are the Lagrangian point, means that will be, satellite will be in the stable position over there, clear, all L1, L2, L3, L4 and L5, clear. So my point it is here, it is we are going to see that it is in a satellite launch vehicle. In 1980 we have started with SLV, 1980 we have started with, I said SLV3 in 1980, satellite launch vehicle first generation. Listen me carefully, satellite launch vehicle first generation, first remember, and thereafter we have started with ASLV, augmented satellite launch vehicle, and it is the second generation and it is in the 1987 ASLV, after the 1987. Then we have moved toward the polar satellite launch vehicle, and it is a third generation satellite launch vehicle, and it started in 1994. 1994. Beta graveyard orbit at the end of the class I will explain you, okay. Those graveyard orbit I will explain you. बेटा वहाँ पे लियो जियो मियो में कोई ऐसा नहीं होता, वहाँ पर नहीं होता, खिंचाव होता है. There is an, I said that one sided, we try to maintain the लियो जियो मियो में कोई हेलो ऑर्बिट नहीं होता है बेटा. वहाँ पे हेलो ऑर्बिट में चाइना ने भेजा था सन और अर्थ एंड मून के बीच में. इट इज नियर टू द मून, दैट हेलो ऑर्बिट इज ओके, नियर टू द मून. तो दैट इज इंटरनेशनल लेवल पर है, दैट इज नॉट रिक्वायर्ड फॉर अस. So Lagrangian geo Leo geo mu is not enough, but China has sent one Lagrangian point between Earth and Moon, that is near to the Moon. इतने नहीं जाओ डिस्कस करने के लिए, नहीं तो फिर तो so many things can be there. Okay, so I said that polar satellite launch vehicle 1994. Let me, when I have started, I am going to give the base of satellite launch vehicle, and after doing this you will be at the top. Like now orbit I have finished with the every angle, and you started understanding, okay, space technology is like this. So I am creating this base now, and after that you will have a feeling of wow again. Okay, so there is an, I said that third generation, it has been started in 1994, PSLV, and PSLV has a 5 variant. We will have to see also what are the different 5 types of PSLV. And now the GSLV Mach 1, GSLV we have started with the 4th generation. GSLV Mach 1, we have Mach means M-A-R-K, Mark, that is Mark, first Mark, you can say Mach 1 we started in 2001, and GSLV Mach 2 we have started in 2010. Clear? So these are the GSLV Mach 1 and Mach 2. I said that, and it is the 4th generation, and the 4th generation is GSLV. First is SLV3, second is ASLV, third is PSLV, fourth generation is GSLV, and GSLV Mark III is the fourth generation third variant, and GSLV and Chandrayaan 2 was sent with this GSLV Mark III. GSLV Mark III has been started, in 2017, just I said that 3 years back. So, perhaps we have seen the important years in the life of launch vehicle 1980, 1987, 1994, 3 in the 2000 series 1980, 1987, 1994. Thereafter, we have started with the, I said that 1980 SLV3, 1987 ASLV and PSLV in 1994. Now, GSLV Mac 1 2001, GSLV Mac 2 2010 and GSLV Mac 3 it is 2017. So, and in the future we will be able to see that is a GSLV Mac 4. Let us, these are the this is the this is the GSLV Mac 1 and 2, this is GSLV Mac 3 and GSLV Mac 4, and one will see in the RLV, and this is the RLV we will see. So, we have to do like, so we are going to start with, I said that I have given some historical aspect of this satellite launch vehicle. Now, satellite launch vehicle. So, we have to do like this. Let us see. First we will do sounding rocket, then we will do SLV3, that is satellite launching vehicle. Clear? Then we will do ASLV. ASLV means augmented, thoda it has been increased, the quality has been increased, power has been increased, augmented means increased, augmented satellite launching vehicle, and PSLV we have to see like polar satellite launching vehicle, PSLV, and then we have GSLV, geosynchronous satellite launching vehicle. Then we have to see RLV and TD, reusable launching vehicle, TD, technological demonstrator. TD means demo like technological demonstrator. It will be not the real RLV, but it will be, I said that reusable launching vehicle will be it is a demonstrator, and we have done that in 2016 and it was successful. And another it is SSLV, a small satellite launching vehicle. So, the generation 1 is this one, first generation, ASLV second generation, PSLV third generation, GSLV fourth generation, and they are the different, but we have not started with, I said that RLV. SSLV is not at that level that we should say it is a generation. So, these are the 4 generation. Now, we have to say like I said that sounding rocket, we have to start with the sounding rocket. Before it, I should see these rockets uses some, I said that fuel, okay, and try to remember these fuels. Once you remember these fuels, you know that you can be very much clear, because ultimately in your Deepavali, if you have seen that, there is a stick and you know, and here it is fuel is there, Okay, it is putting the pressure and then payload above there it goes upward, yes or not. So, similarly there is a I need to know about the rockets. We do not know about the, I said that what are the, I said different chemicals are inside the rockets that we are firing during the, I said Deepavali, but we should know that in the similar way something is working here, like satellite we are sending into the upper space. So, we have to see like fuel or propulsion which is required. There are the three fuels are there. One, it is solid fuel, okay, and there is a liquid fuel, and another it is cryogenic fuel. Okay. I will give you the basic of all this, then I will go into the other part. You should understand how and what. You know that if I am talking about, if there is a 1 kg solid fuel, 1 kg liquid fuel and 1 kg of cryogenic. I am not getting into this, abhi kya hai, kaise nahi. I will say that this one will give more thrust. It will give the liquid fuel, burning of liquid fuel is giving more energy, more thrust in comparison to, I said that, solid fuel. So, यहाँ पे energy produced by 1 kg liquid fuel is greater than energy produced by solid fuel, and the energy produced by cryogenic is, I said that, is greater than the 1 kg of cryogenic fuel is giving more energy than the liquid fuel. Okay. So, perhaps you understand that if I am having these three types of fuel we have, that is, I said that required to give the thrust, solid propulsion, liquid propulsion fuel and the cryogenic, these are there, but you know that the problem is there. I can handle, suppose you know that एक बार ऐसा हुआ करता था, means if you go and ask your mother, and earlier the people, how do they are cooking their food with the help of burning solid fuel like coal. They are burning coal and sometimes cow dung cake. Okay, cow dung cake, they are, what is I said that combustion of this, they are giving the fuel energy. But if you have seen that when we are in the liquid form, some gases are there. Perhaps you have seen that it is, I said, LPG. You know that sometimes in the gobar gas, you can say in the rural areas, in our houses, LPG are there. They are running for, I said that 1.5 months, something 2 months like that. LPG is running, 15 kg LPG is running for 1.5 days. But if you are cooking on the coal, so it needs to be, I said that in a 1 day, if you are utilizing the same, the 20 kg of 10 or 15 kg of coal, you have to burn since morning till evening 3 times. So you have to consume more fuel to get the same energy, yes or not, and then in comparison to LPG. If I have a much better fuel, then I will consume less. So I am giving in a comparison, but one problem is there. Earlier when the LPG came, it was not easy to handle. The people are not understood that liquid fuel, how to handle it. Sometimes they open, the gases are also coming out. That can cause different kind of, I said, that's problem to the people, and sometimes I say fatal occurred. In the sometimes blast occurred, sometimes if you have seen, like I said, that when the somewhere in the house the fire occurred and there is a cylinder gas is the gas is over there in the cylinder, that it can blast also. So I can say that we can control solid fuel, but liquid fuel, it is, if I am talking about rockets, PSLV and all, the liquid fuel is hard to control, and the cryogenic is further more hard to control. Okay. So, the further hard to control, it is more hard to control. So, what is the problem? Why we are saying hard to control and more hard to control? Because we do not have technology to control to carry more liquid fuel. You know that I can carry small liquid fuel and I can control, because they are highly thermal efficient, giving large energy, and it is our Indian technology for liquid fuel and the cryogenic engine is not that much better. So, what we are doing in our satellite launch vehicle, we are using more of solid fuel. So, one line I said that we use more of solid fuel because we can control it, and we can control it better than liquid and cryogenic fuel. Okay. So, we can means I said that due to the I said that what is the problem is there, what is the problem is there, I said that technological challenge, means if we will have a better technology, and then we can be able to, I said that better liquid fuel will be more utilized, and if you have a much better technology, the cryogenic fuel will be more utilized. So, let us come towards, so perhaps this idea, it is helping you to understand why sir is utilizing this fuel is more. Next point, the next point if I am talking about why in initial rocket fuel is more than why in initial rocket fuel is more than fuel in the latter stage. Like I said that this is in a PSLV, suppose this is this much is solid fuel, then the another it is liquid, has this much is liquid, and this much is the again solid, and this much is liquid, and here we have what. So, you can be able to see, like I said that in the first stage solid fuel utilized is very high, then in the liquid fuel is comparatively low, and further solid fuel is further less, and further again liquid fuel is further less. Because if I am saying that it is keep on decreasing in the amount, first it is just I am saying that if our earth is there, if this is our earth and I have to send the satellite, and this is the atmosphere. The first they have to cross the atmosphere, and initially to cross the atmosphere solid and liquid fuel is utilized. So, the somewhere atmosphere is also the earth gravity and atmospheric friction is putting the pressure on the satellite or satellite launch vehicle to be what, decrease their speed. So, at that time I need more thrust, to go out. Therefore, the first and this stage are comparatively I said that larger in amount, and as it comes out with the less energy, we started moving to the higher height and then coming into the particular orbit. So, this is the one thing that I have said that why in the initial rocket fuel is more than the fuel in the latter stage rocket, And then there is another one, why we are using solid fuel in the initial stage. Generally, the reason behind we can solid fuel we are using more, the reason behind we can control the large amount of solid fuel, but we cannot control large amount of liquid fuel. This is the one thing. Perhaps these points are clear. I said that there are the three types of fuel. One it is solid fuel, another is a liquid fuel, another is cryogenic. Understood? Beta, it is all thing that all of you are saying it is good, means we have done giving good amount of thermal efficiency, means energy liberated by liquid is much better than the solid, but you know that it is depending upon how much we can control. It is the technological challenge. So now we are going to see these points. Generally I do not discuss, but in this class I thought let me discuss this. I said now we are going to see solid fuel, and then solid fuel utilize HTPB. Its full form is hydroxy terminated polybutadiene. Please remember this, don't forget polybutadiene. Hydroxy terminated polybutadiene, hydroxy terminated polybutadiene, hydroxy terminated polybutadiene. This is the solid fuel, okay. And if I have enough fuel, then I need also to burn it. Suppose it is in a container, suppose there is in a container and I put into this HTPB, and this HTPB is in a fuel, and this fuel cannot burn without oxidizer. We need oxygen also inside the container. So I need an oxidizer, and that is somewhere it is in a percolate, different kind of potassium percolate and all. So percolate of different solid substance act as an oxidizer. So here will be in the some amount, there will be in some amount, there will be, I said that, and there will be in some amount, there will be oxidizer, and oxidizer help in combustion. So what will happen? So that the total weight, if somewhere it has been said like, if it is said like S139, so what is the meaning of S139? S means solid fuel, and the solid fuel is HTPB, solid fuel, and it is in a weight is 139 ton. The total ton of solid fuel is, S means solid, and 139 means the total weight is 139 ton, 139 ton, and 1 ton means 1000 kg. So you can say that 139 ton, and if it is written, and this means that if it is written S9 means it is again solid fuel, but the weight of the, I said that fuel is 9 ton, and remember that, and if I say that it is S7, if I say that S7, what is the meaning? The solid fuel, and the solid fuel is HTPB, hydroxy terminated polybutadiene, and along with the, and it is, I said that 7 ton. You know that if I am talking about 139, 9 ton and all, it is the weight of fuel also oxidizer. Means this total rocket engine weight is 139, in this one HTPB plus oxidizer, HTPB plus. So if there will be 139, there could be, I said that 110 kg may be a HTPB, and the rest 29 kg can be of what? Oxidizer. To what? For oxidizing and the combustion of it. So it will be the combination of both. So S139, S7. So, and if it is considered an S12, S12 means it is solid fuel, and the total weight of the engine in of this that it is solid fuel and oxidizer, it is, I said 12 ton. Perhaps this point is clear. Yes, okay. So, the solid fuel is HTPB and their oxidizer is there. Another point that we are going to see, liquid fuel. And in the liquid fuel, the two things are in the consideration. Liquid fuel is large and liquid fuel is in what? A small amount. In a small amount and in the what? Large amount. So, I said like it is there is a, if I say that L42.5, it means what? Liquid fuel, and the weight of the fuel is 42.5 ton. Clear? Weight of the liquid is 42.5 ton, and here if it is, I said that L2.5, so here it is, L means liquid fuel and then the weight is 2.5 ton. Clear? But what is the basic difference? Here it is and here it is. In this one, if you will see in this one, in the large one, we are utilizing UDMH plus N2O4. UDMH means unsymmetrical dimethyl hydrazine. Unsymmetrical dimethyl hydrazine. This is the fuel, and nitrogen tetraoxide is, then I said that oxidizer. UDMH, unsymmetrical dimethyl hydrazine, and nitrogen tetraoxide, it is known as what? Oxidizer to burn or for the combustion of the fuel. And in the small amount there is, I said that MMH, MON. MMH means monomethyl hydrazine. Monomethyl hydrazine and mixed oxide of MON. Mixed oxide of nitrogen. Mixed oxide of nitrogen. So, MMH. So, when there is a large amount of liquid fuel is there, and if it is a large amount means there will be UDMH, that you have to remember, that it is UDMH, unsymmetrical dimethyl hydrazine. This is the fuel good for, it has been found and good for this liquid fuel, and then oxidizer, it is, I said that nitrogen tetroxide. It is also mixed oxides of nitrogen, but here it is, I said that in the small amount, when it is known as L2.5, it is a liquid fuel and then weight is 2.5 ton, and then we have utilized MMH and MON for the liquid. It is monomethyl hydrazine and mixed oxide of nitrogen. So, this is we have seen about the liquid fuel, and if the large fuel of liquid, it is known as Vikas engine. This is also known as Vikas engine. That it is this L42.5 is also known as, this is, I said that UDMH, nitrogen tetroxide, that is oxidizer, and this is known as a Vikas engine. And if you will see the full form of it, it is in a Bikram Ambalal S for Sarabhai. So, on the basis of Bikram Sarabhai, I said that this name has been given, Vikram Ambalal Sarabhai, Vikas engine. The liquid fuel is also known as, I said that Vikram Ambalal Sarabhai. Perhaps this is clear to you. I said that liquid fuel, absolutely okay. There are the two types of fuel right now we have seen, solid and liquid fuel. Let me revise it once. I said that here it is a solid fuel. If I said HTPB is there and some percolates are oxidizer. hydroxy terminated polybutadiene and oxidizer are Prograde, and then S139, S9, S12, S7, if it is written, it means these are the different types of engine rockets, and their weights are this one, and it will be STPB, and it will be, I said that hydroxy terminated polybutadiene along with oxidizer. If I say that what is the liquid fuel is there, the liquid fuel is generally, if it is a large amount and a small amount, and it is written L42.5, means it is an unsymmetrical dimethyl hydrazine and nitrogen tetraoxide as an oxidizer. And another point we have been able to see, like I said, that the total weight including this is considered this engine of L42.5 is known as Vikas engine. If it is a small amount of like I said L2.5, means 2.5 ton of what I said that liquid fuel of MMH and MON, means monomethyl hydrazine and mixed oxide of nitrogen. Perhaps it is clear to you. So, I said that there is no concept, but there is a little bit of facts, and some concept are there which I have explained along with this. Another, it is I said that cryogenic. Cryogenic engine, if I am talking about, or fuel. So, here it is I said that this is the cryo, means working on very low temperature, very low temperature. If I am talking about what is the meaning of cryosphere, so we can be able to say, sir, it is Antarctica, cryosphere. Sir, we can be able to say Arctic region, cryosphere. You can be able to say, said that in the higher mountainous region where the glaciers are there. So, cryosphere is like this, yes, and somebody said that at present the global warming is affecting cryosphere. So, somewhere they are melting. So, cryo means anywhere the temperature is what, very low. So, we have been able to see that very low temperature. So, here we have a liquid hydrogen, we have liquid hydrogen as a fuel and a liquid oxygen as I said that oxidizer, and hydrogen is a gas, oxygen is a gas, but they have to be in the form of what I said that liquid. So, at minus 253 degrees Celsius, hydrogen is in liquid form, and oxygen in the I said that minus 183 degrees Celsius. So, we have to put I said that these fuels, liquid hydrogen and liquid oxygen, inside the engine at a very low temperature. So, we can be able to say that this fuel inside the engine or rocket, at a very low temperature and in the form of liquid hydrogen and liquid oxygen, that is in a cryogenic, and that is in a cryogenic. So, it is already very low temperature, then how do combustion can take place? How do combustion can take place? This is the question mark. This is, you know, that if already we have to maintain the very low temperature to remain in the liquid form, and then we have to also do the combustion of it, we have to burn it also. Getting my point? Then India does not have this technology. Okay, this is the fuel, but India does not have this technology. India does not have this technology. Clear? So, I am going, this is clear to all of you. This is your cryogenic fuel, and the cryogenic fuel is liquid hydrogen. If you want to get the better understanding, then I can go little further in the cryogenic. Otherwise, I know that after this all the students, they are also not knowing outsider, those who are studying since 2-3 years. So, I say that this is the liquid fuel, and there it is, I said that problem is here, the fuel inside the engine is at a very low temperature, means cryo, then how do this can go for combustion? This is a major problem. This technology India doesn't have. Okay, and India, and let me tell you, 1980, I said that 7 one multilateral export control regime has been formed. Multilateral export control, it means export control, it is, and I said that at a very large level of dimension I need controlling the export. I will do it these things in the nuclear technology I will do. I said that in 1987 there is a multilateral export control zone, that is, its name is MTCR. It has been established, means Missile Technology Control Regime, and Russia, USA, several countries is the member of it. Russia, USA, Australia, and several other countries are member of, मैं थोड़ा सा समझा रहा हूँ, only for the, I said that for this cryogenic aspect, for the member of the Russia and USA, several other countries are the member of, I said that MTCR, missile technology. Means what is the meaning of missile technology control regime? So those who are the member of this MTCR, they have one important point. MTCR, when they are the member, they have to control the export of rocket technology. They have to control the export of rocket technology, and one, it is unmanned air vehicle also, but here I have to stick with this. And rocket technology, you know that rocket means missile, that you know that in the same way, this is our first stage, second stage, third stage, fourth stage, and here it is missile I am launching. In the similarly, our Agni 1, Agni 2, Agni 3, Agni 5, there are the intercontinental ballistic missile. It is able to reach to the China and any part of the country world. There is also same way rockets are there, and here it is, we have warhead, nuclear warhead. So in here I am sending satellite, and here I am sending nuclear warhead. Getting my point? So it means if I have a technology of space technology, I will be also good at missile technology. I will be also good at what? Missile technology. It means I can use the technology of space technology in the satellite launch vehicle, rocket technology, I can utilize in the missile. Then you can think of, and missile is not good for the world because it is of mass destruction. It causes what? Mass destruction. I can China can threaten us, Pakistan can threaten us, I can threaten us others. If I have this intercontinental ballistic missile, I have this, we have an Agni series like this, and China has a Dongfei, we have an Agni 5 which can cover whole China, and then China has a Dongfei. So they have covered, they can cover the whole India, they can strike the whole India, and they can finish it with the help of nuclear explosion through this technology. इसका मतलब है कि somewhere space technology of rocket help in the development of, I said that missile technology in the defense sector. So I said that Russia is a part of MTCR, and it has been said that in the MTCR we have to control the export of rocket technology. I should not give rocket technology. So any member of MTCR should not give the technology of rocket to anyone else. इतना मैं फिलहाल बता सकता हूँ, but I'll go into the detail when I'll come into that, I said nuclear technology class. So here it is. So this point is clear. If suppose you are a member of missile technology, MTCR, missile technology control regime. So will you give the rocket technology, fuel technology to the other country? If he will give the fuel technology to the other country, he will learn the how to make the rocket and then he can make their missile. So it means somewhere you are against the MTCR and you have to go out of this. लेकिन यहाँ पे एक फायदा भी होगा, लेकिन वो सब चीजें हम लोग बाद में देखेंगे. Let us come on to what I said that in 1991 cryogenic crisis. In 1991 that we are talking about cryogenic crisis, and the meaning of cryogenic crisis, listen me, in 1991 Russia promised India to give cryogenic engine and its technology, and Russia is a member of what? MTCR. So he was, whether he knows or don't know, because if he is the member then he should control the export. So this is the point, it is 1991, then what happened? He was about to give in the 92. They promised in 1991 to give a cryogenic engine and Russia has already. And he said that I will give you the cryogenic engine and cryogenic technology. And he was about to give, then this is the period of 1991. The second it is coming of 1992, USA said Russia to not to give as per MTCR. क्योंकि 1991 में ऑलरेडी जानते USSR जो रशिया है that has been disintegrated and he become what I said that weak. So 1992 में he has to say that okay I am an MTCR member so I cannot give. So this is the problem there. Russia did not give what? Cryogenic technology. Did not give cryogenic technology. Now India become like this. Oh yeah, I have lost. Why? Due to the MTCR. This is the crisis. And India in 1994, and cryogenic engine always in the top. It is in a very sophisticated, yes or not? So we can't use in the down, because in the down I need solid and the large amount of side, and the cryogenic utilizes in the upper stage, upper one. So 1994 India started cryogenic upper stage project. India started making its own project for developing the cryogenic technology, and by reaching 2014 India got it. So late, huh? India got the technology of cryogenic, means liquid hydrogen, liquid oxygen in the engine and to burn it very effectively. So this is the crisis, and somewhere it is the cause of India is not successful in the GSLV. I will discuss. So perhaps this is clear to you. I have discussed with you three types of fuel. There are the three types of fuel. Now India is a member of MTCR. Now India is a member of MTCR in 2016. But it's too late. India became the member of MTCR in 2016. India became the member of MTCR in 2016 when India developed his own cryogenic engine in 2014 itself. But there is so much benefit. When I will come into the defense technology, nuclear technology, this MTCR is helping too much to India, and China is not the member. I will discuss about S400 and so many things. Then you can understand, oh, why India is getting benefit in. Our S400 and China S400, there is a big difference. He cannot do something, and when I will do that, then it will be better for you. So, I said that now India is a member, but that is not fulfilling the purpose of India as far as the cryogenic engine is there. So, now what I said that we have said that there are the three types of fuel: solid, liquid and clear. And it is better to understand that I am giving a very basics and then creating a high level of knowledge to you, that it is a solid fuel can be controlled, and liquid fuel can be controlled, but not in large amount, and the cryogenic engine can be cryogenic fuel can be controlled, but it is in a not very large amount, very smaller amount it can be controlled, and we have been able to develop. Solid fuel, it is HTPB along with some perchlorate as an oxidizer, and HTPB means hydroxy terminated polybutadiene, and the liquid fuel, it is, I said that there are the two types it can be. There is you can be able to see UDMH and nitrogen tetraoxide, means UDMH means unsymmetrical dimethyl hydrazine and nitrogen tetraoxide L42.5 means liquid fuel is UDMH and nitrogen tetraoxide, but there will be also the total weight of this, and this is also known as Vikas engine. Understood? And there are another side, if I am showing you, it is another side, it is what if I talk about if it is a small amount L2.5, there it is the fuel is not UDMH but MMH. I said monomethyl hydrazine and mixed oxides of nitrogen, clear. And thereafter cryogenic, I have said that it is in a cryogenic, and I have discussed also why we have to put more energy and thrust into the first in the rockets, so that we can come out of the gravitational force and the atmospheric friction of the earth atmosphere. Thereafter we started using less amount of fuel, and we have been able to also say that it is we are more of solid fuel because of technological challenges. And thereafter it is, I said solid fuel may HTPB, and the liquid fuel is this one, this one, and the cryogenic I discuss about the liquid hydrogen and the liquid oxygen, and it is an oxidizer, and the temperature -253 और दोनों में difference देखोगे तो 70 का difference है, so that you can remember like this. And this fuel is inside the engine rocket at a very low temperature, but it is a very smart job and technical job to what do burn it or combustion of this fuel at a very low temperature. That technology need to be, India does not have the technology, so there is another issue is there. It is an issue is what I said that cryogenic crisis. So before that I have said about in 1987 MTCR has been, it is a multilateral export control regime. Multilateral export control regime is in the form of MTCR, Missile Technology Control Room, Australian Group, Wassenaar Arrangement, Nuclear Supplier Group. These are, I said that multilateral export control regimes, okay, where they control the export and save the world from the, I said that large destruction. They can do the large destruction. So MTCR, and those who are the member of MTCR, they have to control the export of rocket related technology and all. फिलहाल इतना ही समझाया कि rocket related technology. And when in 1991 and the USSR has I said that promise to provide India to cryogenic engine and technology, then USA said no, MTCR, it can lead to the mass destruction. Satellite means you are giving the technology for the satellite, but you can use it for the, I said, missile also. So this is the thing that it is there, and therefore India started its own, I said its own project, that is cryogenic upper stage project. 1994 and 2014 we got this, and this is the one thing that I have said. Now is India a member? Yes, India is a member of MTCR and he became in 2016. Now we are going to see sound, and we are going to see there is a solid fuel, you know that already, solid fuel, and another is I said that liquid fuel and cryogenic fuel. Solid fuel, if I am talking about in India in India, if we can be able to see, it is solid fuel is general, it is forming in Kerala Thiruvananthapuram, in Kerala Thiruvananthapuram Vikram Sarabhai Space Center, Vikram Sarabhai Space Center, where the solid engine is formed, solid engine, कहाँ पे बनता है, where it is, Vikram Sarabhai. If I am talking about S139 engine, कहाँ पे, where it will be formed, Vikram Sarabhai Space Center, Thiruvananthapuram. This is the Thiruvananthapuram, Vikram Sarabhai Thiruvananthapuram, the capital of Kerala. Clear? Here it is Vikram Sarabhai Space Center. The next one that I am talking about, where this engine of liquid fuel and cryogenic is forming, and I have to say that three regions. First I said first one I said first I said Wali Mala, second I said Bangalore, and third I said Mahendragiri. So Wali Mala, Bangalore, Mahendragiri. What are the three names I said? Wali Mala, Bangalore, Mahendragiri. Beta, we have cryogenic technology, cryogenic fuel technology we have got in 2014. So there is no need to be getting this kind of, I said that benefit. हम लोग अब दूसरे type of, we are getting different kind of benefit from the MTCR, but right now we have already developed before becoming the member. Cryogenic technology means cryogenic fuel technology. I am talking about how to make this and utilize as an engine to launch it into the upper space. So I said that where this liquid fuel and cryogenic fuel fuel is under the engine is under the formation, and then Wali Mala is again in the Thiruvananthapuram, Kerala. Wali Mala is a place, it is a place in Kerala, in Kerala, Thiruvananthapuram district. There is one space Wali Mala. Clear? There is one space is Wali Mala. So I can say that this fuel, this engine is forming at Wali Mala, second it is in Bangalore, and third again Tamil Nadu, it is, I said that Mahendragiri. So they are the three regions for liquid and cryogenic fuel. Please remember it. Liquid fuel and cryogenic fuel are, and their engine are formed in Wali Mala, Thiruvananthapuram, Bangalore, everyone know the ISRO is there itself, and then I said Mahendragiri. And where the solid fuel engine is forming, it is Vikram Sarabhai Space Center, it is in Thiruvananthapuram itself. It is clear? So we have been able to see the different types of fuel. Now we are ready for our, I said one aspect. In Thiruvananthapuram, there is, I said that one again Thumba, perhaps आपने सुना होगा, that is Vikram Sarabhai Space Center is in the Thumba, and there is a Thumba equatorial rocket launcher. Thumba Equatorial Rocket Launcher, TERL. Vikram Sarabhai Space Center, it is in Thiruvananthapuram, it is in the Thumba place, it is the place, and from there we used to launch rockets, and that we started doing sound means Thumba equatorial rocket launcher, naam se clear rocket launcher, and we started in 1963 here, and we are sending maybe on a one stage rocket or maybe a two stage rocket, and these are solid. The two stage solid and there the one stage solid, and there is some satellite is there, and it goes to the 100 or 200 kilometer above in atmosphere to study atmosphere. And what is the purpose of it? To study atmosphere, you know that troposphere, stratosphere, all these are there, and in the 15 kilometer height troposphere, 15 to 50 it is stratosphere, 50 to 80 it is mesosphere, 80 to 400 it is ionosphere. So, to study atmosphere, especially in the ionosphere, and here it goes, and to study atmosphere, and it is known as also experimental purpose. So, when you are doing some experiment, then you think of, okay, these are the electronic equipment I have made, whether it will function or not, and how it is behaving in the space. So, we used to send some, I said that experimental aspect, some rockets, that is known as a sounding rocket. So, we are doing what I said, that this is I am talking about sounding rocket. So, what is the sounding rocket? It is in a one or two stage solid fuel rocket, which is sending in the low earth orbit, very low earth orbit, 100 and 200 kilometer height, where we have to study the atmosphere and how do the missile behavior is there. So, it is an experimental. So, when there is an experimental, it is known as sounding rocket, experimental, not in the higher space. I am saying the low earth orbit. In the low earth orbit, you cannot send it for the longer time because it has to fall down. Okay, so sounding rocket is always near to the 100 to 200 kilometer. Understood it? So, we have been able to see, like I said, that sounding rocket, and we are launching since 1963. Even if I have to send something for the, I said that experimental purpose, we will utilize Thumba equatorial rocket launching. Otherwise, always we are launching all satellites of India from the Sriharikota, that is in the Andhra Pradesh, that is in the Pulicat Lake. There is an island, it is Sriharikota, you know that. So, but for the sounding rocket, we are sending it from Thumba equatorial rocket launcher, that you should remember. Okay. Sounding rocket, perhaps it is clear to all of you. It is an experimental purpose. Because suddenly sometimes we are studying, suddenly the word comes sounding rocket. Yeah, what is this sounding rocket? Okay. The sounding rocket We are using cryogenic engine beta. We are using cryogenic engine in the GSLV. We are using right now. Just wait beta, everything will come. If we have developed in 2014, thereafter we started using it in our GSLV. अभी तो हमने start ही नहीं किया. I said that coming into this, when I teach you GSLV at that time, cryogenic engine will come. TERL, and it is, and I said that sounding rocket. Perhaps this page is clear too. Only beta it goes, we are giving sufficient amount of fuel to study the atmosphere, and then what are the equipments. It will not be remain over there for longer time. After that it fall below the in our ocean. So we no need to go for all this. So there is nothing requirement like this. Clear? So it comes and fall because it is only for few days. It does an experiment. And then after, what is the impact? There is some equipments are there, electronics are there in the satellite, and they also study during that atmosphere and then fall down in the ocean after a few days. Okay. So in case of sounding rocket, we are sending it into the what I said. Lower 100 or 200 kilometer, because it will not it will fill the atmospheric drag, but even then for few days we keep on making it to move to study the atmosphere, and after that it fall down into the what ocean. So that we have seen. I have put my mic over here, okay. It's fine now? Huh? So now that the question was, one student has asked, sir, you have told us to sir, in the lower Earth orbit it should not be below 400 kilometer. I have told you that Hubble scope, these are there, they keep on giving some energy to remain in the atmosphere, but at the same time here I said that I can send into the 100 and 200 kilometer to height with some energy. They keep on rotating for few days, revolving around the Earth in an orbit, and they find out what is the impact of atmosphere on the satellite equipments, and they are also doing some experiment to study the atmosphere, and thereafter it falls down into the, I said that, ocean. So this is very simple sounding rocket, and TERL is in Thumba. It is in Thumba is in Thiruvananthapuram. In Thiruvananthapuram is a district, and within the Thiruvananthapuram district there is a Thiruvananthapuram city. In a district there can be 2-3 cities. So there is a Thiruvananthapuram city, and nearby 20 kilometer nearby to the Thiruvananthapuram there is a Thumba, where it is a Vikram Sarabhai Space Center, and also there is a TERL from where we are sending sounding rocket. So its importance is only up to this. Later on when you will become very intelligent, then I will give on to the, because I will be going with you some basics of this space technology and nuclear technology, then I will come for the advanced studies. So here it is, I said then I will talk about what is the Thumba and how it is behaving. First take these classes, understand it. Beta, it is not choice. It is good for India to join it, and the world community said that come India, join us. It is right now, don't ask, otherwise I will stop here. In the MTCR I have said that I will discuss in the nuclear technology, but your question start coming in this class, in the space technology. It joined not by the choice, it joined not compulsory. Beta, all these things will come, I will tell you. I will tell you. Let me teach here. So this is your sounding rocket, and I said that it is for the to study atmosphere and then experimental purposes. Now I am coming for, I said that SLV3, and SLV3 is, I said that you can be able to see here, it is in the file of SLV3 has been started in 1980 and it is the first generation. This is clear, and it is 1980, and here we have a 4 stage. 4 stage, it has 4 stage rocket, and 4 stage rocket, and all are solid fuel, all solid fuel. And you know that what is the meaning of solid fuel? HTPB, clear? And they can carry, this is the first, we can be able to say, like I said, and this is the first stage rocket fuel, and then there is a second stage rocket, then third stage rocket, and there it is 4th stage rocket. And here we have what? Payload, that is satellite payload. And then payload means how much it can carry? It can carry 40 kg, 40 kg satellite. SLV3, which has been started in 1980, it is in a 4 stage rocket, and all are solid, and it is able to carry 40 kg payload. And we have done 4, I said that such satellite has been sent, 4 times it has been sent. Out of that 2 are successful and 2 are unsuccessful. Clear? So we have got the half success and half unsuccess here. When in 1980 we started, and we have sent 4 times this satellite. So, and from the Sriharikota we are sending, and only the payload, you know that we are sending, it is up to 40 kg. Now the India thought, okay, we are somewhere comfortable by sending the payload of 40 kg in the 500-600 kilometer height, and it is able to move and it is able to perform, but the 2 unsuccess means 50% we are successful. Now India has started in the 1987 after the 4 experiment on this. It is an all our experiment. It is, and I said that it is, the payload should be of 1200 kg, for 800 kg, 500 kg. We have to send a little larger. Okay, so it is an also experimental, you know that, but not experimental in the lower atmosphere, 100 200 kg. 100 200 kg kilometer means, I said that what? Experimented, it will under the frictional drag it will fall down, but this SLV3 it will not fall down, it will remain in the upper atmosphere 500 600. So it is also experimental. Do you understand the difference between experiment of sounding rocket and then I said that experiment of SLV3? In the sounding rocket it is 100 200 kilometer and it will fall down in the ocean. This will not remain in the orbit. First point, sounding rocket. Second point, sounding rocket, it has been sent for the study of atmosphere and then how do the electronic equipment of satellite will function. Okay. But SLV3 which has been sent the 40 kg satellite into the atmosphere, and this satellite will help the people of India by taking the picture. Yes or not? So now it is an experimental in the form of how much we are moving ahead, whether we will be able to have a better space technology or not. So on the basis of this, now after the 2 success and 2 unsuccess, India become little confident. okay, I can send. Next stage, the second generation comes, and it is starting in 1987, and this time it has been sent, I said that 5 stages. 5 stages, on all are solid, all are solid, 5 stage rocket, and this is, I said that 5 stage rocket has been sent, and all are solid fuel, and we are able to come to know that it is carrying 150 kg payload. This payload now it is 150 kg. So payload is becoming 150 kg, means it has been, payload has been what? Increased, augmented. Therefore, the 1987 is known as augmented satellite launch vehicle. So we increased one more rocket, one more stage rocket has been increased one more, and then we are able to send, I said 150 kg of payload. Somewhere it looks okay, we can do something, we can add more and more fuel, better fuel and high fuel, we can launch high amount of payload into the, I said that, different orbits. So we can be able to say, like I said that this is a developmental, India has developed, okay, now I can send satellite. So developmental, this is, I said that developmental, remember this is, आप भी जानते हो, when you started studying, तो आप क्या करते रहते हो, experiment, you started understanding, now developmental, now one day I will not be with you, but you will be able to understand the questions, you will be able to understand the current affairs. So that you have evolved, okay. So initial stage is, I said that okay, sir has taught, you started studying, and then sir taught, it is your understanding experimental, but when you are going and reading it and again you are starting developing. But when the satellite, this space technology will get over, you have understood, you developed yourself, now evolution process comes, means I said that you can handle the current affair, you can handle the question asked in the prelims, mains, means it is evolving yourself, you are evolving, now I am not there. Clear? So this is, I said, ASLV is in a developmental, because here we have tried to increase the payload and it is going into the, I said that, upper atmosphere. So that becomes developmental. But even then I can say that there are 4 in which 2 are successful, 2 are unsuccessful. It is good for India even then. So these are the 2 stages we have seen, and now we are coming towards PSLV. India is ready to evolve. Ready to evolve, and India is ready to send commercial satellite. No experimental, no developmental. Which one? Commercial satellite. इसीलिए आप सुनते होंगे PSLV C20, C18, C37, different kind of C45. It is in a commercial, I said that, satellite. So in the third generation PSLV, we started in 1994. Polar satellite launch vehicle. And where is the polar orbit or sun synchronous polar orbit? It is in the what? It is in what? Polar sun synchronous polar orbit and polar orbit. You know that it is in the low earth orbit. And here we started sending, and that is, we can be able to say, like I said, 4 stage rocket. Okay, and there is alternate solid and liquid fuel. There is an alternate solid and which fuel? Liquid. There is an alternate solid and liquid fuel, and this time the weight has been highly increased. Rocket weight is highly increased. And I will come on to this. These 3 things are clear. I said 1994, 4 stage rocket, and it is alternate. So I am going on to the here it is Pslv in general. So, I am making a picture of Pslv. Here it is L 2.5, S 7, L 42.5, S 139, and here the payload, and payload I can say that 1200 to 1750 kg. Payload. Suddenly from 150 kg we come towards, and you can think of, and there are the 4 stages, and at the same time I can say there are 4 boosters, and you are able to see the 3 boosters, but at the 4th one is at the back. These 4 boosters, sorry, 6 boosters, so there are 6 boosters surrounding it, and 6 boosters. You can see that there is a booster here, 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 and similarly there are the 6 boosters. Okay, they are the 6 boosters. Earthquake? Earthquake. It's too much. It was shaking here, no? Where is the corner?
अभी नहीं है, नहीं है, अब नहीं है, कोई
heavy one, no? The whole building was shaking. पूरा building में टेबल हिल गया पूरा.
हम लोग 2 आदमी बैठे थे, दोनों आदमी से
सोमा कितना भूकंप तो आज तक हम लोगों ने अपने लाइफ में नहीं सुना.
ये 2 महीने में था,
जब से कोरोना है तब से. Set all.
अभी तो ठीक है. स्टूडेंट पूछ रहे हैं आपको यही आता है.
It was shaking the. On the road, road पे नहीं पता चलेगा. On the road you can't ना. When a person, लोग एकदम शांत से बैठे हुए हों तो उसके बाद वो पता चलता है ना कि हाँ कुछ हुआ है. And it was very calm condition over there. Suddenly the table started shaking and all. Huh? Yes, it is an earthquake in Delhi. There is so many earthquake which has comes in the corona period. We have to, so here I was talking about there is an, I said there is a 6 boosters, there are 6 boosters, and each booster 6 boosters, and each are S9. What is the meaning of S9? Perhaps you understand that. S9 means it is a solid fuel of 9 ton STPB. So here we can be able to see like, so there are the 6 boosters. So the stage 1 we can say that this is the stage 1 is solid, stage 2 is liquid, stage 3 is solid, and then liquid. So stage 1 and 3 is solid, stage 2 and 4 is liquid. And perhaps you are aware of it, S139 means in the stage 1 there is an use of, I said that 139 kg of, it is a large amount, it is a very large amount in comparison to Pslv. It is earlier, it is a 139 ton, you can understand that 1 ton means 1000 kg, and liquid it is L42.5, and the third stage S7 L2.5 in the fourth stage. So, and there is a boosters, it is also known as or strap on motors, means motors strap हैं, यहाँ पे straps लगे हैं, and that will first burn it and boost the upliftment and thrust upward of the satellite. And these are the 6 boosters. If I said that these 6 boosters, and each booster is of S9. So you can think of S9 means around 9 into 6, 54 ton of boosters, and you can think of 139 ton of this, 142.5 ton of liquid, S7 2 point, so much of fuel is there, and it is putting a thrust, and in the low Earth orbit, PSLV can launch a satellite in the low Earth orbit. In the low Earth orbit, it is, I said that 1750 kg, and you know that if this is our Earth, and I have sent in a 1750 kg in the low Earth orbit, maybe 600, maybe 700 kilometer above. Now, but if I have to send in the Hohmann transfer orbit, or in the, I said that from the Hohmann or geosynchronous transfer orbit, means I have to use the, if I have to use in HTO, or better to say GTO or geosynchronous transfer orbit, so that I can send in the 36,000 kilometer. So we have to, if I have to take an I have to go for elliptical orbit. So I have to reduce the weight, because PSLV having the same, that is, I said that it is 1750 kg using in the low Earth orbit, 1750 kg using in the low Earth orbit. Here I can establish 1750 kg, but if I have to send into the further longer, then to increase its efficiency to carry ahead into the higher orbit, so I have to reduce the weight, and the reduce can go up to 1200, maybe 1400, okay, 1400, it depends on. I said so thereafter the 1200 kg is the 1200 kg of satellite can be sent in the geosynchronous transfer orbit, and it can establish at 36,000 kilometer. It can establish at 36,000 kilometer. It means I said that if I have to send into the low earth orbit, the weight can be established in the low earth orbit 500, 600, 700, 800, 900 and all, it is 1750 kg. But if we have to go for, यदि मुझे 36,000 in the 36,000 kilometer if I have to establish, means I have to go through geosynchronous transfer orbit or home and transfer orbit. Means when I have to home and transfer orbit, every time I have to come here and I have to utilize little fuel here. यहाँ पे थोड़ा सा फ्यूल मुझे यूज करना पड़ेगा, तो मैं क्या करूं, व्हाट शुड आई डू, आई विल सेंड, इफ आई हैव टू सेंड 36,000 आई विल सेंड 1200 kg, so that when it is coming at this height 1200 kg, then the PSLV will have, you know that in the low earth orbit how much it can come, 1750 kg. But if I send 1200 kg, so the fuel consumed will be less. If I am sending in the low earth orbit 1200 kg, the fuel consumed will be what? Less. And when the fuel consumed less, then always what I will do, when it is coming here, then this fuel will be burning and it is making it to coming into the what? Elliptical orbit, and finally it is always, and through the Hohmann and transfer orbit it is able to reach in the geosynchronous earth orbit, or it can go up to the Chandrayaan, it can go up to the Mangalyaan. If I have to go to Chandrayaan, the weight should be around, I said that maybe 1100 kg. If I have to go to the Mangal, on the Mangal planet, that is I said that 800, 900 kg. So we have to keep on reducing the weight to make the fuel to be that much which can make it to move further and further. So we have been able to see, like I said that PSLV, I said that general, PSLV general, and what is the PSLV general? What is the PSLV general? I said now the earthquake is over, no need to worry about. Such kind of earthquake is regularly coming, and it is not of high intensity earthquake. Okay. So PSLV general, they are the 4-stage rocket. They are the 4-stage rockets, solid, liquid, solid, liquid. Perhaps you understood S139, L42.5, and L42 point, you know that it is also known as which? Vikas Engine. Clear? And thereafter S7 and L2.5, and these boosters are there, that is also known as the strap on motors, and they are S9, and that is surrounding this one, it is boosting it, and it means let us go for it, and one will try to see the one you can now understand. There it is the same, it is showing the PSLV. Means I said that first booster, 6 booster will finish and it will separate, and after when it will be the booster, 6 booster, after burning it, it will separate. There will be, I said, S139 engine will, I said that burn and it will separate. Then the L42nd stage will burn, and it is L42.5, it is known as Vikas engine. It will burn, and when it will finish off, then the third stage it is an S7 solid fuel, it will burn, and then after finishing of it, it will be L2.5, and this L2.5 is not one, they are the two L2.5. remember that if I am talking about, there will be a L2.5 is not one, it is a 2. दो रहेंगे. I will show you in the picture also. The 2 L2.5 engine will be there, and when these liquid 2.5 mmH and mixed oxide nitrogen, it will burn out, then thereafter satellite will be remain fixed, and the satellite after reaching into the atmosphere, it will open its solar panel so that they can keep on making their energy. So here you can see this. I said that here the 6 boosters keep on burning and it is moving into the upper atmosphere. 6 boosters keep on burning, moving into the upper atmosphere. That is also strap on motors. strap on motors, and when they will burn out, and it is in a S9 means they have a 9 ton, and when they will burn out, then the stage 1 S139 they are separating, they are going to separate now, and as it will separate, the S139 will start burning. First stage solid propellant S139 engine will start burning, and it is further boosting. Abhi bhi it is under the atmosphere. If you are watching it, it is in a cloud they have covered. The cloud can be up to the 12, 13 kilometer, 14 kilometer, 10 kilometers. Now first stage separation it will be there if it has burned out, and then second stage it is, I said that Vikas engine of L42.5 liquid fuel will burn, and further it will make it to what I said that fairing separation means, I said that satellite top portion will remove. Why do the satellite top portion? Because they are feeling less friction from the atmosphere, because it has moved above this. So that is known as upper portion. Soon then the second stage it will be, I said that removed, and the L42.5 Vikas engine has been burned out completely and separated, and now S7 is burning, 7 ton of what I said that solid fuel STPB is burning, and this third stage after moving further ahead it will also burn out, and it will, I said that separate, because there it is, I said that there is no need to have a, we have moved out of the friction of the atmosphere. Now less energy is putting more thrust, and then now S7 is going to, I said that burn out, and it will separate. Now this is the third stage separation, S7 is going to separate, and when it has been separated, the fourth stage has been, I said that ignited. You can be able to see there the two, one it is one here it is, one here it is, there is an L2.5, 2 is burning, and then so the two small liquid engines of 2.5 in the fourth stage it is burning, and it has been burned out, and now satellite has been established in the particular orbit, and now satellite for their own energy it will open their solar panels. Okay. So this is the way, and they have also some energy of their own. Okay. So this is the way we have been able to see. You just understood this video earlier, I have shown in the first review, one of overview class was there also. Beta, as much you can see, there it is, I said again, I will make it to you can see this again if you can. Beta, this is the graphics. I just go for it. Already I have given the all idea. Before I said that, let me, I have said what I have said that first who will go? First I said that first stage engine will burn out, booster will burn out, then I have given all picture. So I am just giving the one more better imagination over there through the graphics. First 6 booster will burn out, okay, S9. Thereafter we have, and I said that S139 solid stage will keep on burning and keep on pushing the thrust upward, and S139 burn out, and there will be a separated. Now there will be L42.5, that is the Vikas engine. Yes, I have discussed a lot solid fuel, liquid fuel earlier, and then L42 point burn out, and that will be separated by the time it is reaching far ahead, 500, 600 kilometer, 700 kilometer height. And now thereafter I said that S7 will, I said that burn out, then 2 L2.5 liquid 42 mmH and mixed oxide of nitrogen, it will burn out, and then satellite has been established in a particular orbit around the earth. So when it has been established in a particular orbit around the earth, then the solar panel has been opened, and it will, I said that, making their I said that movement and the function over there from, it is, I said that Pslv, and this is, I said that the falling portion will remain act as an this I said that first stage, second stage, third stage, fourth stage will act as a space debris. They will not go anywhere here and there. It will be boosters are falling into the ocean, and but the rest of it, I said that the stages which are there, they will remain into the upper atmosphere, as an I said that it is a stage 1 which will also fall down into the ocean, that is I said that, and but thereafter means solid boosters it will be, and thereafter we can be able to say that S139, and the rest go up to the 300-400 kilometer by the time, and then L42.5 remain into the upper space, their rocket, and they are creating as an what I said space debris. Yes, we need to send a rocket in a specific direction. First, this is clear to all of you. This is known as the Pslv G, and this is considered, and I said that Pslv. This is, I said that it is known as Pslv G means general. Pslv G means general. We started in 1994. This Pslv general. Understood? All the things are, perhaps it is clear to you that how it is. If I have to send in the geosynchronous transfer orbit or Hohmann, the weight should be accordingly less, and then if in the lower earth orbit 1750 kg. So we have been able to see this one Pslv general. There are the 5 more variants. Beta, there is an as far as the software it is an and all such kind of it will not be hacked, not at all, never. Okay. So next point that we have to see, there is an 5 variants Pslv G, Pslv Ca, Pslv XL, Pslv QL, and Pslv DL, and one more variant has come, Pslv 3S. UPSC can ask anything. So these are the 5 variants, and then one more variant has been added this year, Pslv 3S. But even in the books, if you go, only they are talking about this Pslv G, Pslv Ca, Pslv XL. They are not talking about QL DL. So QL and DL, Pslv QL and Pslv DL has been included in 2019, and Pslv 3S has been included in 2020. And you will understand why they are the different variants, and the different variants must be for the some reason they have included. Understood it? So Pslv G is clear to all of you. And that I have said, this is the thing Pslv G we discussed about. Now one more question, write down one question. What are these boosters are stuffed with? These boosters are stuffed with, I said that, solid propellant beta, solid fuel of HTPB. These boosters are stuffed with solid fuel. These boosters are having, I said that, solid fuel, and if I have to carry in the Hohmann transfer orbit and geosynchronous transfer orbit to further go into the higher earth orbit, and the geo mein jana hoga, if I have to go into the geo, I'll use less amount of payload. Payload will be of 1200-1400 kg. Books are writing like 1425 to 1750. The 1750 means they are, I said that in the low Earth orbit, but if I have to send further, then I will reduce the weight so that the energy can be sufficient amount to make it to into the elliptical orbit to go to the geosynchronous Earth orbit. So, this is then a home and transfer orbit. Yes, if I have to increase further and further, suppose I said that in a car 10 people will sit, then if the car will consume more fuel. If the car will in the car, if there is an I said 6 person are sitting, then the weight to be carried by the car will be less. If the car in the 4 people are sitting, then it will carry the consumption of the fuel will be less. Generally, if you are carrying the suppose in the front and the left 8 people are sitting, then most of the time you will run your car on the second and third gear, and suppose in the mountainous region. But there are the only 3 people, then you will move on to the 4 gears, fourth gear and fifth gear at 4th gear generally, because in the 4th gear the less amount of fuel will be consumed. So, if I have to carry a satellite to the far distances, the satellite weight should be I said that reducing. If I have to go for further far, then we have to reduce the satellite weight to be less. Therefore, it is very much important. Then हम लोगों ने we thought how to increase the weight. The GSLV is increasing the weight. The right now we are doing only PSLV, and the PSLV thought is here. Yes, PSLV further stage it is considered as an I said that GSLV, that is a geosynchronous. So, I will come on to the do not be have an what I said that curiosity beta, where we are try to understand that point only. Okay. And I will start the next class from I said Monday, and it will start with the why we are launching our satellite from the eastern part of the I said that eastern part of the continent and from the desert. These are the questions will be there. I will handle that question. Thereafter, I will go for the PSLV next variant and other importance of it. Then I will go GSL, RLV and the other points. It is clear. So, now you can ask your questions if you have. Now, you can ask your questions if you have. No beta, this is the 4th stage. L 2.5 it is in the 4th stage, but the 2 here it is the 2 nozzles are there. It is not the 5 stage, it is the 2 nozzles. They are burning in one time. If it is burning in one time, it is considered as a 1 stage. We are the thing is there. If I will go into the PSLV different variants, then you will come to know about this question why we are adding or not. Clear? Instead of adding, we can do increase the weight. S139 के जगह we can do S200. If I will do S139, instead of S139 we can do S200. It means there will be more thrust and it will go more further. That it will be done in the GSLV beta. Graveyard orbit beta and the graveyard, and I said that GTO, I have explained a lot beta. Graveyard orbit, suppose I said that this is our earth and this is our earth, this is our earth and this is Leo, this is Meo and this is I said Geo. This is Geo 36,000 kilometer. If it is 36,000 kilometer beta, so if I'll in the case of Leo Meo, this is the Leo, this is the Meo, the satellite in the low Earth orbit and middle Earth orbit, they will not be able to fall down towards the earth because they can be able to I said that causing I said that several accidents and there will be more collision and there will be more space debris. So if I can't make Geo to go down again, geosynchronous Earth orbit 36,000, if it is this satellite, if I will start making it to move down, it will keep on colliding. The simple language I am telling you, and it will create more debris. So again I am telling you, I have taught you earlier that it is the satellites of MEO, LEO cannot go down, and after that I said that GEO also cannot go down, so that the satellites of MEO and LEO, they will keep after their operational life, they will remain over there as a debris, and they are known as space debris. Understood? As if I have sent the PSLV boosters after burning separated, they come into the ocean. Thereafter the first stage S139, after burning they also come into the, I said that ocean, but thereafter L42.5 and then other S7 and L2.5, they have gone into the upper space. They always move like a space debris. When it moves in the 500 kilometer, 600 kilometer height, this debris, and then finally satellite reached up to the 800 kilometer, then those removed stages of S7 and L2.5, they will remain as a space debris around the earth. This point is clear to you? So low earth orbit, medium earth orbit, all remain into the after their operational life. When the operational life finishes, they remain as a space debris. As far as the GEO is in concern, he can't also after their operational life, if he will be here. Now if I talk about MEO, if wants to come out, if I will take the MEO, to come out, so they will strike with the GEO. So in the case of MEO, LEO, you can't do anything. It will remain after their operational life as an debris, but in case of GEO, I can make it to move out of the orbit, and out of the orbit above this at a 300 kilometer height, it is acting as an graveyard orbit, and you can see here like here, this is in a geostationary earth orbit 36,000 kilometer, and I have to only increase the speed, and this satellite will come out of the orbit of GEO and move 300 kilometer. 300, this is, I said that it is a 300 kilometer above the GEO. This is a graveyard orbit, because our satellite, if it will go away from it, it will I said that not utilizable at all. So we will make it I said that graveyard orbit. That much right now I can tell you. Beta, combustion technique in the cryogenic fuel means liquid hydrogen, liquid oxygen, when it started burning, that is known as cryogenic technology. India doesn't have in 1991, but Russia has, USA has, already they have they are burning their cryogenic fuel, and when they are burning their cryogenic fuel in such condition, it is known as the cryogenic technology they have, and India is able to adapt adapt this technology and make this technology by the 2014. Other country has, what is the meaning of cryogenic technology? Means they are able to burn the liquid hydrogen and liquid oxygen. But again you are asking the same question, how do the second time I am talking about, here you can see this picture. I said I sent the satellite in the low earth orbit and it is moving in the low earth orbit, okay. Then मैंने यहाँ पर जो and in the HTO, when I have to send in the HTO or GTO, both are same. HTO or GTO, both are same when it is established. But if I have to send in the transfer orbit, then I will have to use the satellite of low weight, 1200 kg, 1400 kg. Then our launch vehicle will have some energy. Then what I will do, when it is coming here, then यहाँ पर ये जलेगा and it will go into that, it is थोड़ा सा यहाँ पर जैसे ही ये move कर रहा है, like you have seen ना, जैसे ये it is moving like this, so it is moving like this in circular orbit in the low earth orbit. So what will happen, here the fuel will burn, क्योंकि मेरे पास थोड़ा सा फ्यूल बचा हुआ है, बिकॉज आई हैव टेकन द लो वेट सैटेलाइट. इफ आई हैव अ लो वेट सैटेलाइट देन ऑल द फ्यूल विल नॉट कंज्यूम. So here I will say that this fuel will make it to burn, और जैसे ही burn करेगा तो it will move in the elliptical orbit. जैसे कभी कभी क्या होता है ना, if you are increasing the speed then it will move away. Your ball when you are making it circulate, if you are increasing the speed, so it will move away. Similarly if I increase the speed, it will start taking this elliptical orbit. फिर again this satellite came here and again came here, again I burn it, then again it takes a little elliptical orbit. Again he came here, again I burn it, it came into the elliptical orbit. Further again I burn it, and all these elliptical orbit जो भी आप देख रहे हैं, what are they are GTO or HTO. So to make it to in the HTO, I have to utilize the fuel which are saved, which are not consumed. Then this not consumed fuel is always making it to come over there. Now it come at the 36,000 kilometer. Now after coming here I have to be maintain this circular orbit. तो हम लोग क्या करेंगे, अब थोड़ा यहाँ एनर्जी दूंगा मैं, यहाँ पे जैसे ही बर्न करूंगा सम, then it will come like this. If I'll burn then I'll come out of the orbit, then I came like this. Again I said that यहाँ पे लिखा है ना orbit after burn one orbit, then again I burn, then after that I came into like 36,000 kilometer. Means burning only small time. I'll show you that movie when I'll show you Chandrayaan 1. Later I'll show you Chandrayaan 1, like what is happening in the Chandrayaan 1. And the Chandrayaan 1 has been also sent by the Pslv XL. It has been sent by the Pslv XL. There is a 6 boosters. In 2008 it has been sent. But this time the weight that we are taking, the weight is little less than, I said that 1750, and it is around 1400 kg, 1200 to 1400 kg. 6 booster burn out, and S139 has been burning, and S139 has also burn out. Now L42.5 is burning. Fairing separation का मतलब होता है that the satellite का बाहरी cover हटना, the outer it is removing. Now S7 will burn and out. Now third stage S7 has been burned out, and now it is, I said that L2.5 fourth stage, it is burning, and there is some energy in the satellite. There is some energy in the satellite which has been increased in the satellite, and they are moving here, they are keep on moving, and whenever it comes here it is burning more extra energy. Like you can see here, when it is moving near to the earth, there you can see here it is burning and make it to move out. तो ये थोड़ा सा out move कर गया, that it is looking like elliptical away from the earth. Now it is coming again closer to the earth as it is earlier. Again here it is burn out, here again he burned the fuel, again you can see there it is burning the fuel, and again burning means again it is taking extra far orbit, it is coming little far. This is the home and transfer orbit, or better to say that geosynchronous transfer orbit. Again it is coming near to the earth, and then again it is burning. You can see that again it is moving far, and slowly you can see that it is able to reach moon, near to the moon. And when it is reaching near to the moon, under the gravity of the moon, they started moving around, yes, moon. That I can show you, but to wait for all this. No बेटा, यदि मुझे लियो का ही हम लोग, it is not easy to send, we cannot maintain. If I'll send into the any other region, they can if I'll give something, if it is in a Leo and you are sending Sir Van Allen belt, if I will send it, it can go to the any region, because we have these are the that is we need a fuel to make it to move, and technology need to be to what I said that to establish in a particular region. We have to establish the particular orbit also. When it is going into the, if it is from the LEO, it is I am making it to go into the Van Allen belt. A student has asked, sir, क्या मैं LEO से उस debris उस that satellite can send into the Van Allen belt? Beta, we will try to send it, then it cannot be maintained, because every time we have to maintain a particular orbit. So it can go to the any other, maybe it can go to the MEO, he can strike with any other objects. We have to maintain a particular orbit. So problem of controlling in a particular orbit. And it will be the same day he will be able to reach beta. It will in the same day, because the speed of it it is very high. The same day and the next day it will be able to reach. Probably, that is I said that depends upon the weight, maybe 2-3 days. Yes, it is very much important, because PSA, the Chandrayaan has been, it will be taking, I said that only 20-30 minutes to PSLV variants. The questions are coming, which satellite, which variant of PSLV is able to send. My question is, it is question to all of you, my question to all of you, tell me, if I have to send a 800 kg satellite, 800 kg satellite, then which PSLV should be utilized? Now my question is, if I have to send a 800 kg satellite, which PSLV should be utilized to send it? First answer my question, if I am sending, if I have to send an 800 kg satellite, so which PSLV can be utilized? My question to all of you, if I am sending a satellite of 800 kg, should I utilize PSLV G, or we should utilize any other we should utilize any other PSLV? If I have to send a 800 kg satellite, I should send the satellite from PSLV G or PSLV other variant. Show me your talent, beta, everyone show me your talent. My question is, if I have to send a satellite of 800 kg, which satellite I should utilize the PSLV G and born. PSLV G has been made for sending the satellite, PSLV G has been made for the sending the satellite of 1200 to 1750 kg. 1200 to 1750 kg, and if I have to send the satellite of 800 kg, then I will utilize the PSLV G or some other variant, because the weight of this time weight of satellite is only 800 kg required to send. My question, if you are able to understand, PSLV G can carry 1200 to 1750 kg, 1750 kg in the low earth orbit, and if I have to send a further one, then I should utilize less weight of PSLV. So this is the character of PSLV. But if I have to utilize, if I have to send a 800 kg, then should I utilize the same PSLV G or some other PSLV which can consume only less fuel and send the 800 kg satellite? if you are and I said that this is the, if it is an earth and PSLV G can carry, here it is 1750 kg. But if I am talking about मुझे 800 kg भेजना है, तो should I take the same, this is S139, this is I said that L42.5, S7, L2.5 of 2, I should consume, केवल मुझे 800 kg भेजने के लिए, to send only 800 kg, I should waste this much of energy. To send only 800 kg, I should waste, or I should utilize other variant. I should waste this S139, L42.5, 7 ton of third stage and 2.5 ton to liquid of fourth stage. So मुझे इनको यूज करके मैं सारा इंजन बेकार करूं, इतने ज्यादा, so much of large amount of fuel I should waste for sending 800 kg, I should take the another variant. I should send some other variant of PSLV which can consume less fuel. I should send some other variant which can consume less, या same PSLV G. If I'll send with the other variant of PSLV which consume less fuel, then I can save the fuel. Now tell me, I should send with the other variants or the same PSLV G. बेटा मुझे 800 ही भेजना है, I have to send the 800 because it is not easy. You know that if I am talking about an engine of S139, I can't make it less. मैं S139 में सर you just fill 100 kg, 100 ton, it cannot be, because there is a pressure system in a particular engine. S139 means I can't put 100 tons of solid, I can't put 100 ton, I can't put. So simple thing is there that we should utilize other variant, we can consume less. Therefore there are several there are other variants of PSLV. Do you understand that? One student was asking, sir, what is the use of studying other variants? So therefore I said, now tell me, my question is, that is clear, perhaps it is clear to you. If I have to send Chandrayaan 1 and if I have to send Chandrayaan Mangalyaan Pslv, in the year 2013 I sent Mangalyaan and 2008 we send Chandrayaan, but with the help of PSLV. So I should use PSLV G, or I should use PSLV XL, extra large, for Chandrayaan 1 and Mangalyaan 1, I should send with the PSLV extra large XL, or we have to send with the PSLV General. My question, in 2008 Chandrayaan 1 has been sent to far distance and Mangalyaan 1 has been sent in 2013. So I should send the PSLV through the PSLV G or PSLV XL. Let me see how much you are understanding. क्योंकि this is I said the moon is 3,86,000 kilometer away, and Mars planet is around 4 crore kilometer away. It is around 3.4 crore, something like this. So I should have a PSLV engine of extra large or PSLV of G. I should use PSLV extra large या PSLV G for Chandrayaan and Mangalyaan. Because you can understand that I am sending the satellite to be very far. It is not in the 36,000 kilometer in the geo, but it has to be sent very far, that is 3,86,000 kilometer, and better energy. I should have a more energy to go further and further. Lots of time I should be in the HTO. If I have to move in HTO for several time to go to the Mangalyaan, I should use PSLV XL use करेंगे बेटा. Some of you are, most of you, 95% students, you are writing PSLV XL, but understood, because if I have to go far and far, then I should have a better energy. Simple idea, everyone knows. यदि मुझे बहुत दूर जाना है, यहाँ पर जाने के लिए PSLV G है, but if I have to go far, then my engine should have more and more energy. Then I should take the another variant PSLV XL. Some question has been asked, PSLV Chandrayaan 1 and Mangalyaan 1 has utilized which variant of PSLV? Then you should know PSLV XL. अभी मैं teach नहीं कर रहा, I am not teaching. One student has asked, why should I study the different variants? Perhaps you understand that there are variants which is sending the different size of satellites, and I should save our fuel. Sometimes if I have to send far, I should use the PSLV of high quality. If I have to send lower, less distances, I should utilize the PSLV of less quality, means higher and lower. It depends upon the weight and the distance where we have to send. My point, you understand that PSLV XL is required to far. There are 5 variants. I will teach in the next class. Let me teach in the next class so that you can understand. Perhaps all of you are getting what I want to say. It is clear to all of you what I want to say. It is clear to all of you what I want to convey you. बेटा अभी नेक्स्ट क्लास में विल डू द वेरिएंट्स. इन नेक्स्ट क्लास विल डू द वेरिएंट. बेटा लेकिन लेस वेट कैन बी कैरिड अप टू द सर्टेन हाइट ना. लेस, इफ आई से दैट ओके यू आर सेइंग सर मैं 1200 kg यहां तक लेके जाऊं, लेकिन मुझे इफ आई नीड, लिसन मी केयरफुली, I said that, listen me, you can understand that. Suppose I said that this is the earth and 1750 kg, and I am talking about PSLV G, okay, and in the low earth orbit I can send 1750 kg, and in the geosynchronous earth orbit I can send 1200 kg, okay, that is okay. But if I have to send a 1500 kg in the Chandrayaan, कैसे भेजूंगा? Tell me how to send 1500 kg in the Chandrayaan. 1400 kg, 1400, 1500 kg जो भी है. in the 36,000 kilometer I can send that suppose 1200 kg, but if I have to send a 1500 kg, तो मुझे क्या करना होगा, my PSLV quality should be better, more fuel to be utilized, yes or not? Further I have to increase little more fuel, further I have to increase further more fuel. Beta, do you know that PSLV, all these 5 variants is highly successful in the world. None of the satellite, whether it is you are talking about Elon Musk, if you are talking about NASA, if you are talking about Russia, China and anyone, PSLV is the most successful satellite launch vehicle in the world. Out of 50, only 2 are unsuccessful. Out of 50 launches, only 2 are unsuccessful. You can think of how much it is, and 1 is partial unsuccessful. 2 unsuccessful, 1 partial unsuccessful. Then you can think of how much percentage of success is there. Highly, people are having high faith, and the world communities come and say that you send my satellite with the PSLV, you send my satellite with the PSLV. So foreign countries, even USA is coming and sending their satellite from the PSLV. So do you understand that it is very much important? I can finish with the PSLV, okay, this is the PSLV now, perhaps you understand. But if I will touch the variants, now the UPSC is not asking what you understand, he is asking what you are not understanding, and it is not given into the books and all. So UPSC is asking your understanding, logical clarity of space technology. I am trying to increase your logical clarity. Yes, it is a proud for India. It is a proud for India that India has a highly successful launching vehicle in the world. No such PSLV. There is a PSLV का कोई तोड़ ही नहीं है. That is the PSLV, the highly successful satellite launch vehicle in the world. Out of 50 launches, 2 unsuccessful and 1 partial unsuccessful. Perhaps my point of view is very much clear to you. So therefore it is very much important to study. So Saturday and Sunday will be off, and we will meet on Monday, and that day I will finish, and you should be very much clear with the idea and all that I have given today and in the yesterday classes. So I have to finish in the next 2 days on Monday and Tuesday, that it is about our this is space technology. Clear? Your question, Ravi Prakash, your question is not clear, beta. Yes, class is over now. Class is over. It is ended. PSLV is made by India, developed by India. बेटा क्रायोजेनिक इंजन इज कॉस्ट इफेक्टिव कैसे, कहाँ पे बोला, when did I say that cryogenic engine is cost effective, cost efficient? I did not say cost efficient. Good night beta. After space technology you can see the other notes beta, and you will think of, there are very useless things are given in the book. try to go with my notes. Thereafter you can take any book. I can't say for any book, but I say that the my notes will be good for you, and current affair that you should do. Good night, beta. Thank you. Thanks to all of you for your cooperation and the support. Thanks to all of you that all of you are cooperating me. Good night. So I think that your question is over. Vikram? It is not required. How combustion take place? हमें साइंटिस्ट नहीं बनना है बेटा. Even I don't know how do combustion take place. I should not know about the how do the combustion should take place. Not at all. Don't be too much. Otherwise, it will be a scientific, highly scientific study. यदि मुझे पता चल जाए and we at the level of student can come to know about कैसे combustion होता है, तो you can think of. It is not. We should not study all this, beta. This is the technology, high level of technology. So many countries of the world does not know. Otherwise, they can use it. To give in a sufficient amount of thrust to cross the atmosphere, beta. Alternate solid and liquid. Liquid is highly efficient, but हम लोग solid से ऐसा thrust देते हैं so that it can cross to a certain extent, then the certain amount of liquid to cross the atmosphere. In the GSLV, in the similar manner, we are using solid and alternate liquid. Okay. If I have a better technology, I can use only liquid, beta, instead of solid. But initial boost, जब गाड़ी को start करनी होती है ना, तो we start at what I said, that we start with the first gear, and the first gear consume more energy at the first time. When we start the car in the first gear, and at the time in the tank where the fuel is burning, that time more fuel goes and the car starts and move ahead very slowly. So in the first stage, I need enough fuel which can be a solid, which can give more thrust. Thereafter, the liquid can be utilized. Yes, in India there are several institutions. You know that it depends upon the government policy. When the government says that yes, private sector can make, if the government says the private sector can make rockets, then it can be made. Now therefore the several rockets are coming, and it is in the news. It is in the news that the several private sector, the ISRO, what is the full form of ISRO? Indian Space Research Organization. But ISRO is doing what? ISRO was doing, I said, the research and also sending the rockets. The ISRO job is to do research in the space technology. In similarly, NASA, if you go to the USA, earlier NASA was doing research and also sending the satellite. Now that NASA has been right now only doing research, and their space station, that Elon Musk, you know that the SpaceX company, private tech companies are now sending the rockets and sending the launching vehicle. In similar way, fashion, then from this year and the next year onward, only slowly and slowly, ISRO will stop sending the launching vehicle. Other private company will come. Valimala and Bangalore and Mahendragiri are made for liquid engine as well as cryogenic engine. Solid ke liye, it is Vikram Sarabhai Space Center, that is in Thiruvananthapuram. Vikram Sarabhai Space Center, it is in Thiruvananthapuram. It is for the solid fuel. Vikram Sarabhai Space Center, it is for the solid fuel. You can say that here it is Vikram Sarabhai Space Center. And the liquid fuel and cryogenic fuel, Valimala, Bangalore and Mahendragiri is there. बेटा अब it is going far, do not ask too much question बेटा. अब आप लोग पढ़ो बार बार and clear your ideas. Googles are also there. Okay, try to read it, and even then the confusion are there, you can ask me. I'll come into the next class so you can ask your question. Okay. Okay beta, good night to all of you.